Hey, what's up, guys? Welcome to my algebraic geometry video. So in this video, we will do an important exercise. This exercise is important, so we will keep using it. So I found that the usual problem for the people study algebraic geometry, including me, is that the Vakil and Hearthstone, that kind of textbook, they don't provide details. So lots of details are in the exercise. So if you don't do the exercise, then you keep reading, then until some critical point, then you will not understand. You will not understand the context anymore. Okay. Okay. So this one is important. Hope you guys subscribe to my channel. So short morphism and pre-sheaf, pre-sheaf, and induce a morphism stalks. So if you have a morphism between sheaves and you want to define a natural map from the stalks. They so prove that they will introduce the map from stock to stalks. Okay, this one is important, so we will keep using it. Okay, so this is morphism from F to G, and so what is the stalks? So f of x, right? Is the ux where or not us, not ux. It's us. Okay, US, where x belongs to u and s belongs to f of u, right? And the quotient some equivalent relation. This equivalent relation say that if us is the same as vs prime, if there is a w is open subset between u intersection w, such that when s restricted from u to w is the same as restricting s prime from v to w. Okay, and the restriction map, some people denoted uvws equals to uvw s prime. Okay, so what is the natural map from fx to what is the natural induced map from fp to gp? So if you ask me, right, I will keep it simply just define that if I start from the US, remember S now belongs to f of u, then I will simply map into the u because they're on the same space, right? So I map on u and S I map into f. So this is morphism of sheaf, right? So this I can map it to phi of u, right? Because this means that given u, I will have the homomorphism from fu to g of u. So I will just simply add f of u and apply on S. Okay, so the remaining is proof that this is well defined. Okay, so simply is that we want to show. The first one is that if you have us vs prime, we want to show that maybe let me just choose using f and g. Okay, we want to show if these they are the same, then the equivalent relation, then the map will be u phi of u f will be equivalent to v phi of vg. Okay, so how do we prove this? So this is why you need, when you try to do this exercise, then you will learn the detail of you will learn the detail of why you need some commutative diagram from the definition of sheaf. Okay, so let me just provide the picture here. Okay, so we will have u, right? So things are equivalent, so we have w, and then we have g of u and then g of w, and then we will have ru w and r. Sometimes I use curly u and this u to be the same. So ru w. Let's call it prime, right? Because that's on g size. And we have the functorial property. So this is phi of u, phi of w. And then we have the similar diagram. So we have the similar diagram for B. Okay. So now let's compute the left right hand side. So we have phi of u f And remember that this means that so this tells you that RUWF is the same as RVWG. Okay, so this tells you that if you start from this phi of UF, and so what do? Right? You restrict it to W. So let's check. Right? If I restrict it, this is weird, right? So phi UVF is some guy which is some guy which at this G of U, right? So then I need to use this RUW prime. So I use RUW prime. Then by the commutative diagram, this RUW prime icon phi of U is phi of W RUW, right? So I can just change it. I can just change this map into RUW act on F, and I take the phi W. Okay, and the list map is what? By definition is RVWG. Right? So I have phi of W and RVWG. Okay. Okay. So now that's working on the this side. If I can show that this side, this guy is the same as this guy, then we finish, right? So let's start from 5VG, and then let's check we act on VW prime, right? We restrict this map, these two in W, okay, using restricted from V to W. Then by this commutative diagram that we have RVW prime phi V as the same as phi of W RVW, right? So we get phi of W RVWG. Okay, amazing, they are the same, right? Okay, basically it's simple, just simply say this, right? Because you use this commutative diagram. Okay, so this is just simple exercise to tell you that the morphism of the stalks, the morphism between the sheaves actually give you the morphism between the stalks. And yeah, hope you guys subscribe to my channel.